Hi friends, see today I will be starting part 3 of electrostatics. In part 2 we have dealt about infinity sheet, okay, that is infinity sheet carrying positive charge. We have derived for that one electric field intensity, okay, electric field intensity as sigma by 2 epsilon naught, isn't it? Yes, sigma by 2 epsilon naught. So ikkada varaku manaki we have completed up to part 2. Now in part 3, as I told you, this is also a very big chapter. In part 3 of electrostatics, now we will be dealing about Gaussian surface of solid sphere outside and inside. Okay, this is the next item today. That is, for example, if you take any sphere, okay, suppose this is a sphere, solid sphere, okay, suppose this sphere is carrying some charge plus q. Suppose this sphere is carrying some charge plus q, and let sigma be the charge density. Now suppose this is center of the solid sphere, let the radius be capital R. Now first of all let us go for outside the Gaussian surface, and for example let us take this radius as small r. Appudu Gaussian surface ela untadi? This is the Gaussian surface, okay, outside the surface, outside the sphere, outside Gaussian surface. Gaussian surface ela undi? Outside undi, meer chudandi, outside, okay. So this is the charge plus q. Now in such cases, I told you this is a 3D figure. In 3D figure you will be having electric, this field always away from the positive charge. Alaga manam mundu class lo cheppukunnam, okay. Electric field will be going from positive charge away, outside. Electric field intensity is, and then negative charge means it is coming towards, okay. Because it is positive charge, it is going away. Now on this surface, if you consider any small surface if you take, that is dA. So as I told you, for 3D figures it will be outside. For 3D figure the surface area is outside, dA. For 2D inside and outside, I told you in the before class. So in this what I will do is I will apply Gauss law. So what is Gauss law? Integral of E dot dA is equal to 1 by epsilon naught times q inside, charge inside. So E dot dA, integral E dot dA. So in E dot dA means dot product of the two vectors, that is modulus of A, modulus of surface area into cos. What is the angle between the surface and E? 0 degrees. That is equal to q inside by epsilon naught. So integral of the closed one, E dA cos 0 is 1, that is equal to q charge inside by epsilon naught. So because E is outside coming uniform, so take it outside common, integral of dA is equal to q inside by epsilon naught. So integral of dA anta A avutundi. So therefore E into A is equal to QA by epsilon. What is A here? Surface area of the sphere. So what is the radius you have taken here? Gaussian surface. Outside తీసుకున్నాం. Outside what is the radius? R. So here outside the radius is R. So put it here. Surface area E into 4 pi R square is equal to Q inside by epsilon naught, or E is equal to 1 by 4 pi R square Q inside by epsilon naught. And you can observe this equation is very famous equation again. It is nothing but again what? E is equal to kq by r square, antena? Where k is 1 by 4 pi epsilon naught, intensity equation. It is the formula for intensity of the electric field. So this is the equation for outside the surface. Clear? Please copy this one. Very, very important. Clear? Right. Now suppose if you take inside, what happens we'll see. Same thing, suppose if you take inside. Same sphere, if you take inside, what happens we'll see. Okay? See, same sphere, suppose if you go for inside, the figure again changes in this fashion. See? Gaussian surface kuda maaripotundi kada inside if you take. So this is the sphere now. Okay? Now suppose if you take inside, see what happens. We'll see. Let us see what happens now for inside. Inside we will try to calculate electric field. So charge is spread outside plus Q. Of course sigma is charge density. Now suppose if you take inside ఏమవుతుంది? Suppose the radius is r. Now r is less than capital R. So inside there is no charge. Inside charge ఏమీ లేదు. అంటే E ఏమవుతుంది? 0. What about E? 0 inside. So inside charge and the spread outside only. So inside there, if you go inside, there is no charge, please. Charge is only outside. What will be the field now? E is equal to 0. Because if you apply your Gauss laws, E dot dA is equal to Q inside by epsilon naught. So E dot A again, if you take any, see E again, మీరు ఎలా చూసుకున్నా because the 3D figure coming outside electric field, and if you take any small surface dA, okay, outside if you take dA and here same direction, angle is 0. Even if you apply here E modulus A modulus cos 0 integral, what is charge inside? No charge, only charge is outside. So this is equal to what? 0 by anything, 0. Okay? So therefore, integral E dA is equal to what? 0. Or even if you take E constant, integral dA is equal to 0. So because there is no charge inside, charge is only outside. So inside, electric field is 0 for a solid sphere. Clear? So this is how you have to explain. Very, very important regarding examination. Now we will try to draw a graph for this intensity versus radius. We will try to draw a graph for intensity versus radius. And first of all, what we will do is conducting sphere. Okay? First of all, we will take for conducting sphere graph. Conducting sphere. Okay? And the sphere may be shell by hollow. It may be shell or hollow sphere. Okay? Shell or hollow sphere. This sphere is not a solid one. Conducting hollow by shell. Okay? Now, దీనికి మనం గ్రాఫ్ గిని ట్రై చేద్దాం. On x-axis distance r and y-axis intensity, electric field. Now, if you draw a graph for this one, this hollow or shell, now the graph goes like this, please. See here, this is origin, 0, 0. Here r is equal to 0, center. This is capital R. Now, if you draw a graph for this hollow or shell conducting sphere, what happens here? Inside, center at r is equal to 0 at the center. And here you can see this is capital R. So, ఇక్కడ ఏం జరుగుతుంది మనకి? As I said just now, inside ఏంటి? Inside E is equal to 0. Charge is only outside. లోపల E 0. Okay? So, because E is 0, in this case, what happens? R at the center is 0 and here it is capital R. So, first ఏమవుతుంది? ఇక్కడ వాల్యూ అంతా less value. Okay? And the intensity will be 0 almost up to the surface, and later on it increases slightly. And then what happens? You can observe it is again inversely proportional. because we know what is the formula for intensity. Intensity is equal to kq by r square. So intensity is inversely proportional to r square. So tarvata after some time what happens? It decreases. So this graph you observe carefully, this is what? E inversely proportional to r square. So gradually the intensity will be decreasing, inversely proportional to r square. First it is almost 0, very less value up to the surface level. This is for shell or hollow conducting sphere. And slightly it rises again and again comes down. So this is the graph, okay? This is outside please, this is outside. Outside somewhere over here, R. Okay? So it is as the distance is increasing, E decreases. So therefore, the intensity gradually decreases. Starting you can see 0. Okay? Almost maintained up to the radius, surface. Surface work almost it is maintained the 0 value. And slightly raised and again it is decreased. Okay? Clear? So this is the graph for intensity versus radius of a hollow or shell sphere please. Please make a note. Inside electric field is 0. Next one. Next one. Let us go for non-conducting surface. Okay? Non-conducting sphere. Second one for non-conducting sphere. Okay? For non-conducting sphere, let us take solid sphere of course. Let us take solid sphere, okay? And it is non-conducting. For non-conducting, generally make a note, okay? Generally inside E is given by kq small r by r cube, okay? R cube. For a non-conducting sphere, solid sphere, please, inside, okay? And for this also I'll try to draw a graph. For this also I'll try to draw a graph. Intensity versus and radius on x-axis. This is non-conducting sphere. This is center and this is radius capital R. And this is inside. And this is outside. Okay? Now for in this case you can see inside what is the formula? K. K and the constant 1 by 4 by epsilon. Q is the charge. Okay? And R is the radius changing outside or inside. Capital R surface radius. In such cases if you see here E is proportional to R. Intensity is proportional to R. So graph first meeku almost here. So almost up to directly proportional kabatti it will be straight line. E proportional to R. And then what happens? Again decreases. Again this is what? E inversely proportional to R square. Outside. Outside again the formula again. This inside is the outside. What is outside intensity formula? Again kq by r square. E is inversely proportional to r square please. So as the distance increases, again what happens? Intensity decreases. Okay. So for outside you can take kq, either small q or capital Q you can take. You can take Q is equal to capital Q charge. Okay. So inside there is no, you can see it inside the formula E bar is given by kq small r. This r is nothing but variation of the radius. Okay, either you take inside or outside. And capital R is the radius of the surface. Okay, so this is the variation of the graph. It is directly proportional and again it is decreasing. So increase avutundi. If R value is increasing, E value is increasing. So surface value work the intensity increases gradually. Tarvata as the radius is increasing, again E decreasing. You can see the graph. Okay, as the radius is inversely proportional kada, radius perigite intensity tagutundi. Radius taggite intensity perugutundi. So this is the graph for outside and inside. Please remember this formula K capital Q R by small r by R cube. Okay na? Shall we go to the next one now? Right? Right. Now, after seeing all these graphs and other things, now we'll do one thing, okay? We'll define what is potential, electric potential at a point, electric potential V at a point, and thereby potential difference, that is delta V. We'll try to define what is electric potential and potential difference. For example, there are 2 points, say A and B. Now suppose this charge plus Q is at A, say. For example, from A I have to move to B by using some external agent, external work. I have to move from A to B. Let the potential at A be VA, let the potential at B be VB. Now in general, how you will define electric potential means it is the amount of work done in moving a unit positive test charge from infinity to the required point somewhere over P against the electric field, against the electric field. So that means you are doing against the work. Again, negative work అనమాట ఇక్కడ. అంటే అర్థం ఏంటి ఇక్కడ? ఎలక్ట్రిక్ పొటెన్షియల్ అట్ పాయింట్ ఎలా డిఫైన్ చేయొచ్చు అంటే ఇట్ ఈస్ ద అమౌంట్ ఆఫ్ వర్క్ డన్ ఇన్ మూవింగ్ ఎ యూనిట్ పాజిటివ్ టెస్ట్ చార్జ్. ఓకే, టెస్ట్ చార్జ్ from infinity to the required point. In general, if you define like this, you can tell the definition. And units also joules per coulombs, MKS or SI unit. Work done ki joules, charge coulombs. Okay, or simply potential ki maro unit code on the simply volts. Potential capital joule per coulomb is also taken as 1 volt. So it is the amount of work done in moving a unit positive test charge from infinity to the requirement. Like that you can define electric potential. Potential difference ఎలా చెప్పొచ్చు? From A నుంచి B కి వెళ్ళాలి. Okay, I have to go from A to B by using some external work. So ఇక్కడ potential difference అంటే ఏంటి? Final minus V final minus V initial is equal to work done. మీకు అర్థం పాయింట్? సో A నుంచి B కి వెళ్ళారు. The person is going from A to B. అందుకే మీకు చాలాసార్లు మీకు ఫ్రిక్షన్లో I think in work done, work power energy, I think I told you regarding the gravitational work. ఓకేనా? మీకు అక్కడ కన్జర్వేటివ్ ఫోర్సెస్ గురించి నాన్ కన్జర్వేటివ్ ఫోర్స్ గురించి మీకు డిస్కస్ చేస్తాం. అక్కడ గ్రావిటేషనల్ ఫోర్స్ ఎలాంటిది? కన్జర్వేటివ్. ఎలక్ట్రోస్టాటిక్ ఫోర్స్ ఎలాంటిది? కన్జర్వేటివ్. దట్ మీన్స్ ఇట్ డస్ నాట్ డిపెండ్స్ అపాన్ ద పాత్, ఇట్ డిపెండ్స్ అపాన్ ఓన్లీ ది ఇనిషియల్ అండ్ ఫైనల్ పాయింట్. అలాగే ఫ్రిక్షనల్ ఫోర్స్ నాన్ కన్జర్వేటివ్, పాత్ మీద డిపెండ్. పాత్ పెరిగితే వర్క్ మారిపోతుంది. ఇట్ డజంట్ డిపెండ్స్ అపాన్ ది ఇనిషియల్ అండ్ ఫైనల్ పాయింట్. సో ఎలక్ట్రోస్టాటిక్ ఫోర్స్ ఏంటి ఇక్కడ? కన్జర్వేటివ్, డజంట్ డిపెండ్స్ అపాన్ ద పాత్, ఓన్లీ ది ఇనిషియల్ అండ్ ఫైనల్ పాయింట్. ఓకేనా? జస్ట్ లైక్ గ్రావిటేషనల్. అదవుతుంది మీకు పాయింట్. సో ఇక్కడ పొటెన్షియల్ డిఫరెన్స్ అంటే డిఫరెన్స్ బిట్వీన్ 2 పాయింట్స్. సో ఇక్కడ చూడండి, ఇక్కడి నుంచి ఇక్కడ వెళ్ళాడు. సో VB minus VA is equal to W by moving this charge. So this is the exact formula for potential difference between any 2 points. A నుంచి B కి వెళ్ళారు, A నుంచి B కి వెళ్ళారు. అండ్ తర్వాత ఇంకో పాయింట్ గుర్తుపెట్టుకోండి, along the direction of field the value decreases also. Okay, later on I'll tell you with some example. Along the direction of the force, okay, the value gradually decreases. Later on I'll tell that value by doing a numerical also. Potential value, okay, you can see here potential decreases with the direction of the E. Okay, E direction ki potential decreases. Along the direction of field, electric field, the potential is decreasing. So what happens? VB minus VA is equal to W by Q again. again joule per coulomb, that is volts. అదవుతుందా? సో పొటెన్షియల్ డిఫరెన్స్ ఏంటి? యు ఆర్ మూవింగ్ ద ఛార్జ్ ఫ్రమ్ ఏ టు బి. సో వాట్ ఈస్ పొటెన్షియల్? ఏ నుంచి బి కదా, కాబట్టి విబి మైనస్ విఏ ఈజ్ ఈక్వల్ టు డబ్ల్యూ. అలాగే సపోజ్ ఇఫ్ యు ఆర్ మూవింగ్ ఫ్రమ్ బి టు ఏ, you are moving from B to A, then VA minus VB is equal to work done by the external agent by charge. And this is sometimes also treated as delta V. Okay? Change in potential. That W is equal to VQ or delta V is equal to W by Q. Work done by the external agent. Okay? Work done by the external agent from A to B. Work done by the external agent from A to B or B to A. A to B means VB minus VA. B to A means VA minus VB. So this is how the definition goes for potential difference and electric potential. Now what we'll do is we'll do one small numerical to understand better this concept. Okay, chinna problem chadam, so that you can understand in a better manner this concept. కాన్సెప్ట్ అర్థం అవ్వాలంటే ప్రాబ్లమ్స్ కూడా చేయాలి మధ్య మధ్యలో ఫిజిక్స్లో, దెన్ యూ కెన్ అండర్స్టాండ్ బెటర్. లెట్ us try to do one small numerical. Now for example, see here the problem is given in this fashion. There are 2 points, namely A and B. At A, suppose there are, how much value it is given? 6 coulombs charge. So charge is given as 6 coulombs from A. Okay? Now from A to B, it is moved. From A to B, it is moved. Okay? To move that one, how much work is done? Work is done as 100 joule per coulomb bata. To move, please make a note, to move from A to B, this is called external agent work. External agent. ఎంత పట్టింది? 100 joules per coulomb. వర్క్ డన్ కదా, వర్క్ డన్ ఫార్ములా ఏంటి? W is equal to VQ. See, we already know W is equal to VQ. Or W by Q is equal to V. Okay? So, ఏమి ఇచ్చాడు? ఒక నిమిషం ఆగండి. What he has given? He has given 100 joule per voltage ఇచ్చాడండి, అదే పొటెన్షియల్ ఇచ్చాడు. Okay? He is given potential. Now he is asking you, in this case, he is asking you, what is the potential at B? He is asking you what is VB. సో ఇప్పుడు చెప్పాను కదా, ఏ నుంచి బికి వెళ్తున్నప్పుడు VB minus VA is equal to work done in moving from A to B divided by charge. So potential at B minus potential at A ఇచ్చాడండి. సారీ, వర్క్ డన్ కాదు అది, పొటెన్షియల్ at A ఇచ్చాడు. అది ఇట్ ఈస్ నాట్ వర్క్ డన్ ప్లీజ్. పొటెన్షియల్ at A ఇచ్చాడు. వాట్ ఈస్ ద పొటెన్షియల్ at A? 100 joule per coulomb ఇచ్చాడు. సో ఇక్కడ ఛార్జ్ 6 coulombs హ్యాస్ టు మూవ్ ఫ్రమ్ ఏ టు బి. ఏ నుంచి బికి మూవ్ చేయాలి. నౌ ఈస్ ఆస్కింగ్ వాట్ ఇస్ పొటెన్షియల్ ఎట్ బి. సో విబి మైనస్ విఏ, వాట్ ఇస్ ద ఫార్ములా హియర్? ఏ నుంచి బి కదవాలి కదా, విబి మైనస్ విఏ ఇస్ ఈక్వల్ టు వర్క్ డన్ బై ఎక్స్టర్నల్ ఏజెంట్ ఫ్రమ్ ఏ టు బై బి డివైడెడ్ బై ఛార్జ్. సో విబి మైనస్ 100 ఇస్ ఈక్వల్ టు వర్క్ డన్ ఇన్ మూవింగ్ ఫ్రమ్ ఏ టు బి divided by charge. 6 coulombs. ఓకేనా? క్లియర్? సో మీకు ఆ వాల్యూ ఇంకేమి ఇచ్చాడు? వర్క్ డన్ కూడా ఇచ్చినట్టున్నాడు కదా, 30 joules ఇచ్చాడండి. వర్క్ డన్ కూడా ఇచ్చాడండి. వర్క్ డన్ ఎంత? 30 joules. వర్క్ డన్ కూడా ఇచ్చాడు, 30 joules ఇచ్చాడు వర్క్. సో యూ కెన్ పుట్ ద వాల్యూ హియర్. VB minus 100 is equal to work done by the external agent ఎంత? 30 joules ఇచ్చాడు by 6 coulombs charge. 6 1s are 6 5s are. So VB minus 100 is equal to 5. VB is equal to 100 plus 5, that is 105 volts. So this is the potential at B, that is 105 volts. So ఈ విధంగా ప్రాబ్లం చాలా జాగ్రత్తగా చేయాలండి ఇవి. You have to understand the concept first of all. Okay, here at A 100 joules ఆల్రెడీ ఇక్కడ మనకి ఇక్కడ పొటెన్షియల్ ఇచ్చాడు. ఏదైనా పొటెన్షియల్ 100 ఉంది వోల్ట్స్, 100 వోల్ట్స్ ఉంది. 6 coulombs has to move from A to B. He is asking what is the potential at B. So A నుంచి B కాబట్టి VB minus VA is equal to work done by the external agent divided by the charge. So VB minus VA 100 ఇచ్చాడు, my is equal to work done కూడా ఇచ్చాడు 30 joules divided by the charge. So 105 is the potential, 105 volts is the potential at point B. See, like this you can calculate any value for any question if it is given regarding the numericals. Okay, now let us go to the next item, electric potential due to point charge. Next one, electrical potential due to point charge. Suppose a charge plus Q is given, point charge. Now P అనే పాయింట్ దగ్గర at a distance R, I want electric potential V. Okay, ఇక్కడ Q is the point charge, then it is given by what? V is equal to KQ by R. K you all know, the constant 1 by 4 by epsilon naught. Epsilon naught is the permittivity of free space. So K Q by R. K is equal to 1 by 4 by epsilon naught. This is the electric potential due to the point charge. Now suppose if number of charges are given, system of charges, for example Q1 అలాగే Q2 అలాగే Q3, number of charges are given at a distances R1, R2, R3. Now at a point P, how to get the resultant? So resultant is nothing but V net. V net potential is nothing but V1 plus V2 plus V3. So therefore V net is equal to V1 means K Q1 by R1, first one. Again, due to second one K Q2 by R2, K Q3 by R3. So you can apply this formula, you can get when the system of charges, when number of charges are given, the net potential also you can calculate by using this formula. Clear? Right. Now next one, let us go to the next point, that is, see in the before class part 2 we have discussed about uniform ring charge. Okay, that is KQR by root over x square plus r square power 3 by 2. Okay, KQX by x square plus r square power 3 by 2. When x is equal to 0, e is equal to 0, x is equal to infinity, z is equal to 0. Only in the middle r by root 2 plus r by root 2 money will draw on graph also. But now what we will do is potential due to this charged ring, uniform ring at a point P. This is center, this is point P. Let this is distance x. Let the radius be capital R or small r. Okay. Now in such cases, how to get the potential at P? It is given by, say, KQ by x square plus r square square root. KQ by root over x square plus r square V. So this is the potential at the point P. In intensity we have seen KQX by x square plus r square power 3 by 2. Now here also you can observe at center x is equal to 0 at center. What happens this one? Potential is given by KQ. Q is the charge, of course. Q is the charge on the uniform ring, please. Okay, and K is constant, you know, as usual, 1 by 4 pi epsilon naught. సో x is equal to 0 పెడితే ఏమవుతుంది, kq by root over ఇది 0 కాబట్టి r square ఉంటుంది, అంటే kq by r. So this is the formula at the center. Okay, this is the formula at center, please. Clear? And you need not go for infinity, please. Infinity కి వెళ్ళవసరం లేదు, వేస్ట్. ఇక్కడ ఇన్ఫినిటీకి వెళ్తే మళ్ళీ ఇది పాయింట్ చార్జ్ అయిపోతుంది మీకు. ఓకే, చార్జ్ పాయింట్ చార్జ్ అయిపోతుంది. సో need not take. So this is the value for at x is equal to kq by r. Clear? ఇన్ఫినిటీ ఒకళ్ళు తీసుకున్న నష్టం ఏదంటే సున్నా అయిపోతుంది, ఇంకేం లేదంటే ఇన్ఫినిటీ దగ్గర పొటెన్షియల్ ఇప్పుడు కూడా సున్నాయే. క్లియర్? Now let us go to the next one. Electric potential at a point P on axial line due to dipole. See, next one is electrical potential V on axial line due to electrical dipole. Okay, you all know this is the poles, north, south, east, west. I told you in the intensity also you got some equations there. 2kp by r cube for short dipole, long dipole ki me pedda equation vachindi 2kp r by r square, that is r square minus a square per whole square. Okay, r అయినా d అని మీ ఇష్టం, ఎంత తీసుకోవచ్చు. కొంతమంది l తీసుకున్నారు, d తీసుకున్నారు, anything can take. But here I am taking a distance between the dipole. Okay, so electric potential, and for example see here, so this is the axial line here, point P. Here you take most of the things are taking 2l, but I am taking 2a distance. ఏదైనా తీసుకోవచ్చు, this becomes a. చాలా మంది d తీసుకుంటున్నారు, but I will take it as r. ఓకేనా, I will take it as r. సో అప్పుడు ఈ డిస్టెన్స్ ఎంత అవుతుంది, r minus a, and this distance will become r plus a. Now we need to calculate the potential at P due to this dipole. సో మీకు అందరికీ తెలుసు, పాజిటివ్ నుంచి ఫీల్డ్ ఎప్పుడు కూడా బయటికి వచ్చేస్తుంది, ఫీల్డ్ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ. ఓకే, బట్ హియర్ వీఆర్ నాట్ క్యాలిక్యులేటింగ్ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ, వీఆర్ క్యాలిక్యులేటింగ్ పొటెన్షియల్ P. సో ఇక్కడ పొటెన్షియల్ P కావాలని ఏంటి, డ్యూ టు దిస్ ఛార్జ్ హియర్, డ్యూ టు దిస్ ఛార్జ్ హియర్, వాట్ ఇస్ ద పొటెన్షియల్, V1 K Q by what is the distance, r minus a. See, if you are using d here, d minus a. If you are using l here, 2l, then here it will become l. మీరు ఏది వాడితే అదే వాడండి ఇక్కడ, ప్లీజ్. ఓకే, జనరల్ టర్మ్స్ ఆర్ యూజింగ్, ఐఎమ్ యూజింగ్ హియర్. సో డ్యూ టు దిస్ ప్లస్ q, వాట్ ఇస్ ద పొటెన్షియల్ హియర్, ఫస్ట్ పొటెన్షియల్ kq by r minus a. And due to minus q, what will be the value, due to minus q at P, k, that is minus k q by what is this distance, r plus a, equation 2. Okay, clear? Now V1 is kq by this thing, V2 is this thing. Now this is minus value and this is plus value. So what is the V net here? V net is nothing but V1 plus V2. Resultant potential కావాలి మనకి. సో V1 plus V2. V1 plus V2 అంటే ఏంటి, ఇక్కడ V1 ఎంత, kq by r minus a plus minus kq by r plus a. ఓకేనా? సో వాట్ హ్యాపన్స్ దిస్ వన్, kq by r minus a plus into minus minus kq by r plus a. This is what, V net, resultant potential. Take LCM, a plus b into a minus b, a square minus b square. Okay na? And I'll take common kq. kq common this ikkada paina, r plus a will be having minus, and here you will be having r minus a. So this implies kq into ఇక్కడ ఎంత అవుతుంది చూడండి, r plus a minus r plus a by a square minus b square. So here what happened, plus r minus r will be cancelled, and finally I will rub this one because I don't have place. Copy. So I am calculating V net resultant potential due to electrical dipole, please, on axial line for long dipoles and also short dipoles. So V net is equal to KQ by R square minus A square. Pi name is 2A. Now we all know what is 2AQ, dipole moment. P is equal to 2AQ. Therefore V net due to axial line for long dipoles is equal to K into P vector by R square minus A square. But for example, if R is very much greater than A, then what happens? It becomes short dipole. So V net for short dipoles is given by Kp by, you can take common here as R square into 1 minus A square by R square. So for short dipoles R very large, so A square by R square can be neglected. So only R square will be left over here. Okay, A square minus B square ante. So appudu emavuthundi manaki idi neglect cheste will be having only R square. So Kp by R square is the V net on the axial line, where P is electrical dipole moment, K constant 1 by 4 pi epsilon naught, and R is the distance at the point on the axial line. Kp by R square. Clear? Right. Now let us go for equatorial line. Let us go for equatorial line. I will write it on the top here for remembering. See, I have got it as Kp by R square V net for the short one on axial line, short dipoles. In the same fashion, let us go for equatorial line, parallel to north-south. Same, suppose electrical dipole, for example, see here, now you can observe here, now the point I have to take on the equatorial line, okay, not here. So these are your dipoles, minus Q plus Q, this is the dipole direction, and this distance I am taking as 2A as usual. Point P I am taking on the equatorial line. You can see parallel to the north-south place. So this distance, I will take it as R. Let this distance be R, okay, and this is A and this is A. Now drop some, extend this line. Now according to Pythagoras, then this is perpendicular, this is A, this is R. So what about this one? Root over A square plus R square. The same way, this kuda root over A square plus R square. Now watch carefully on the equatorial line at point P due to this electrical dipole. So what is V1 at P? What is V1 at P? You can see with the negative, with the sign, because potential you have to write with sign, not intensity. Intensity will be, you can remove the sign because attractive and repulsive there. So here with the sign, minus KQ by D. That is root over A square plus R square. The same way, due to this charge V2, KQ by same distance, root over A square plus R square. So what is V net here? V net is equal to what happens? Resultant ఏమవుతుంది ఇక్కడ? V1 plus V2, V net. ఇందాక చెప్పాను కదా, system of charges ఉన్నప్పుడు ఏం చేయాలి? The sum of all those things. Because electrical potential is not a vector, it is scalar. So sum of all those. So V1 plus V2. So minus k cube by root over a square plus r square plus k cube by root over a square plus r square. Plus minus cancel అయిపోయి ఏమవుతుంది మనకి v net is equal to 0. సో అర్థమవుతున్న పాయింట్ on equatorial line v net electric potential due to the electrical dipole is 0. So v net is equal to 0 in the case of equatorial line for short magnet for short dipole as well as long dipoles. But we will have axial line value kp by r square. R square minus a square, but for short one you are taken as kp by r square. Please note this for things because these are very very important for numericals in NEET examination, especially and also in MCET. Electrical potential due to the axial line and equatorial line, please. Okay, so please make a note, perpendicular you don't have value, only for axial line you have. In the same fashion you can calculate at any angle v, that is r theta. And for example, this is your negative charge, positive charge, distance separation 2a, and this is the direction of electrical dipole. Suppose this is the midpoint a. Suppose at some angle you want, at some point p, at some distance r. Okay, so in this case already you are done for intensity. This is what? ఇది p కదా, ఇది ఎంత అవుతున్నప్పుడు కాంపోనెంట్ p cos theta, and this component p sin theta. Okay, so in this direction already you have calculated there also. So ఇక్కడే అవుతుంది పొటెన్షియల్, ఇక్కడ చెప్పండి పొటెన్షియల్ v on axial line. What we got actually? kp by r square, axial line. So v on axial line is equal to kp. What is the component of p in this direction? Axial line. This is axial line and this is equatorial line. This is axial line, this is equatorial line. Okay, so kp in the terms of p, and this is called p cos theta. In terms of p cos theta by r square. So this is the formula for at any angle, kp cos theta by r square. But what about vertical? V is 0. Just called v is equal to 0. So v vertical perpendicular on equatorial line, okay, his value is 0. Already calculated. Okay, already calculated. Only we'll have on the axial line only, please, at any angle. Clear? So v perpendicular on equatorial line it is 0. Already it is proved in the before case. Only on the axial line we will be having in normal case kp by r square. If angle is given kp cos theta by r square, please, due to electrical dipole. Clear? Okay. Now let us go still further in this chapter. Please try to remember all these formulas. Okay. Now let us go to the relation between V, E and D. Electric potential, electric field intensity and distance. Okay. So for this what we will do is, let us take 2 points. Let us take 2 points. Let a positive charge is there here. Let this charge be at 1, some points 2, 3, 4 are there. Okay. So 1, 2, 3, 4, some distance I have taken. Now suppose if I want it here, this is the direction. Okay. Positive charge means field ఇటువైపు ఉంటుంది కదా, field direction. Positive means away, it is going away. For negative charge it comes towards. Now for example, if you calculate potential here, V1, kq by d, potential at here, kq by d, potential at here, KQ by 3. Potential at here KQ by 4. Now if you observe carefully, this is KQ1, 1 by 2, 1 by 3, 1 by 4. 1, 1 by 2, 1 by 3, 1 by 4. If we take LCM, 12 is to 6 is to 4 is to 3. Which is larger? This is larger. So V1 potential is greater than V2, greater than V3, greater than V4. That means towards the direction of the field, potential decreases. చూడండి, V1 is greater than V2, V2 is greater than V3, V3 is greater than V4. Okay, so towards the field, the potential value decreases from the figure. In the same way, you can try for negative charge also. Okay, same thing will be happening. It decreases. Negative charge field direction మారిపోతుంది. Okay na? Right. Clear? And we have a relation. Just now I told you relation. We have so many formulas for the relation between V, E and D. Many formulas we are having. Out of that I will give some formulas. Okay. One is minus E into dx dv is equal to, or V is equal to minus E into dr, or V is equal to minus E. This is electric field intensity. These two are vectors, displacement. E dot, anything you can write, dy, dx, dr, V. And V sometimes also taken as potential difference, delta V. Sometimes it's also taken as potential difference, delta V. Potential difference. So it is written as the minus of E dot dr, E dot dx, E dot dy. Dot product of these two. Okay. For this understanding better, I will give a small problem. For example, note down this one. If electric field intensity is given as 20 I cap plus 30 J cap Newton per Coulomb units, and a point is given, a point P, 1 meter, 2 meter is given. Okay, you can take it from the origin. This is origin. Point is given 1, 2 meters. Okay, this is R vector, vectorial position, and this one you can write as I cap plus 2j cap. This is, you can write as R vector. Now for this one, we will calculate the potential Vp. So simply what you can write, E dot dr or R minus E dot R. So minus, what is E here? 20 I cap plus 30 J cap dot of R. What is the position vector there? I cap plus 2 J cap. I dot I, 1 into 20. I will write it here. 20. I dot remaining all 0 from the vector properties. And J dot J, 1 into 2, 2 into 30, 60. So 60 plus 20, how much? 80 volts. And what 80? Minus, outside minus only. Minus. So minus 80 volts. So this is how we will be calculating by using the vector method. Clear? Write down. So like this you can calculate the potential relation between V, E and D. We have some more formulas also for V, E and D. Those also I will give you for better understanding. We are having in vector form. Okay? And electric field intensity vector formula is there. For example, sometimes electric field intensity is given as vector form. That is Ex I cap, Ey J cap plus Ez k cap, completely in vector form, x direction, y direction, z direction, exi, eyj, ezk, exi, eyj, ezk. Okay, in such cases also you can calculate the e value. Okay, so e value ఈ సందర్భంలో ఎలా చేయాలి? See, you can calculate by partial derivative. By calculating with partial derivative. And how to get potential V in x direction? That is dou V by dou x. Okay, dou V by dou x. సో dou V by dou x చేస్తున్నప్పుడు ఏంటి ఇక్కడ y, z కాన్స్టెంట్స్గా పెట్టుకోవాలి ఈక్వేషన్లో. అలాగే y డైరెక్షన్లో dou V by dou x ఇక్కడ ఏంటి y, z కాన్స్టెంట్. అలాగే నెక్స్ట్ dou V by dou z. మీకు అర్థమవుతున్న పాయింట్స్ ఇక్కడ మీకు ఫస్ట్ x డైరెక్షను y డైరెక్షన్లో కావాలి వెక్టార్ ఫీల్డ్. x డైరెక్షన్లో కావాలంటే ex, dou v విత్ రెస్పెక్ట్ టు x, yz కాన్స్టెంట్స్. y డైరెక్షన్లో కావాలి ఫైండ్ ద పార్షియల్ డెరివేటివ్ విత్ రెస్పెక్ట్ టు y హియర్. x రాస్తాను, సారీ, y. ఓకే, dou v by dou y. సో ఇప్పుడు x అండ్ z ఆర్ కాన్స్టెంట్స్ హియర్ విత్ రెస్పెక్ట్ టు y కదా, సారీ దిస్ x and z. నెక్స్ట్ అదేవిధంగా ఇఫ్ వాంటెడ్ ఇన్ x, y, z డైరెక్షన్ ఫీల్డ్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ, అప్పుడు ఏం చేస్తారు విత్ రెస్పెక్ట్ టు z. విత్ రెస్పెక్ట్ టు z అయినప్పుడు x, y ఆర్ కాన్స్టెంట్స్. సో లైక్ దిస్ ఇఫ్ యూ ఫైండ్ ద పార్షియల్ డెరివేటివ్స్ you will get x direction field, y direction and z. This is another method, mathematical method, partial derivative. Whatever that v value is given, okay, that means e is nothing but dv by dx or dou v by dou x. Okay, the minus and minus ఉంటుంది, of course, don't forget minus is there, please. Minus dou v by dou x minus dou v by dou y minus dou v by dou z, x, y and z direction. When you calculate with respect to x, y, z constant, with respect to y, x, z constant, with respect to z, x, y constant. This is general formula. E is equal to minus dv by dx or dou v by dou x. Clear? So this is how you will be solving for different problems in such cases. Okay? Now, same thing you can go for electric potential due to charged sphere. This is over. Let us go for charged sphere, electric potential due to charged sphere. Same inside and outside. Mundalage, how you calculate for E? Electric potential for charged sphere. For example, this sphere is there, this center, this is radius r, and suppose q is the charge. Of the sphere. Okay, it may be solid or hollow. Sphere may be solid or hollow or shell. Solid and avachchu, hollow and avachchu. In such cases, okay, and of course it is conducting sphere. Of course it is the electrical potential చెప్పాను కదా, conducting sphere. So in such cases we will try to calculate what is the potential. Okay, what is the potential? Potential V. Okay, see, if you want inside, that means R is less than R. Inside R is less than R. Inside value ఎలా ఉంటుందంటే మీకు ఈ సాలిడ్ కానీ హాలో లేని surface value, whatever value you are having on surface, same thing, that is V is equal to K Q by R. In these type of cases, electric potential charged sphere It may be solid or hollow conducting spheres. In such cases ఏం చేస్తామంటే సర్ఫేస్ మీద ఏదైతే వాల్యూ ఉంటుందో సేమ్ వాల్యూ విల్ బి ఇన్సైడ్. సేమ్ వాల్యూ K you know as that is 1 by 4 pi epsilon naught in value constant. Q is the charge of the sphere and R is the radius. Same value surface మీద ఏముంటుందో inside కూడా అంతే ఉంటుంది. ఓకేనా? And if you want outside here R is greater than capital R. V out, this is V inside. V outside. KQ by small r. Okay, because here R is greater than somewhere over here R. Okay, na? This is the radius R. So R is greater than R kabatti here KQ by small r outside. And inside and surface same value only KQ by capital R only same value. Inside and outside KQ by outside. అంటే సర్ఫేస్ ఒకరు తగ్గితే మీకు ఆర్ పెట్టుకోండి, స్మాల్ ఆర్ పెట్టండి. సర్ఫేస్ మీద అయితే క్యాపిటల్ ఆర్, అదొక మీకు సేమ్ వాల్యూ. ఓన్లీ థింగ్ అవుట్ సైడ్ మీకు మారుతుంది కేక్యూ బై స్మాల్ ఆర్. సర్ఫేస్ అండ్ ఇన్సైడ్ సేమ్ వాల్యూ కేక్యూ బై క్యాపిటల్ ఆర్. క్లియర్? నౌ shall we draw a graph for this one? Potential graph, intensity versus radius. Let us draw a graph for intensity versus radius. Okay, let us draw a graph. So this is radius on x-axis. Here intensity kadandi, potential please. We are explaining potential. So this is a sphere. So potential on y-axis, radius on x-axis. I am taking potential on y-axis. Potential. Radius on x-axis. Observe carefully. This is origin 0 0. This is the radius, surface radius. This is center. Now just now I told you potential is same for surface and radius. Only it is changing for outside. So outside and somewhere over here outside. R is greater than capital R. Okay na? In such case ఏమవుతుంది? As you know, inside and on the surface value is same kada, inside and surface. What is V? KQ by R only. So same value. Now after that what happens again? Outside ఏమొచ్చింది మనకి? V is equal to KQ by smaller. అంటే V is inversely proportional to R. So V is inversely, it is decreasing, you can see. Value is decreasing gradually. Okay na? So surface మీద center there value same ఉంది potential and it is decreasing outside because V is inversely proportional to R outside. Clear? Any doubt? You can say almost it is constant. V inside and surface almost same value kabatti constant. Then gradually it is decreasing. Okay, clear? Right. Now let us go to the next one. Electric potential due to two charges. Electric potential due to two charges. For example, electric potential energy. I mean electrostatic potential energy, EPE. Electrostatic potential energy due to two charges, Q1, Q2. ఇది ఎలా డిఫైన్ చేయొచ్చు? ఫర్ ఎగ్జాంపుల్ ఇవి ఎక్కడో ఇన్ఫినిటీ దగ్గర ఉన్నాయి. Now these two I have to bring here at a point A and B, Q1, Q2. So here I am bringing from infinity slowly by doing some work. So work done in moving those two charges from infinity to the required points A and B slowly. That amount of work is called as electrostatic potential energy, and it is given by K Q1 Q2 by D or R. This is the distance between them. Okay, this is the electrostatic potential energy due to, and K you know 1 by 4 pi epsilon naught. K value meeku eppudu telusu 1 by 4 pi epsilon naught constant. So this is the formula for electrostatic potential energy due to two charges Q1 Q2. And it is the amount of work done in moving those two charges from infinity slowly to the required point. So K Q1 Q2 by D or R. Okay, and please make a note, Q1 Q2 should be kept with signs, proper signs, with proper sign convention. Q1 Q2 should be kept with, suppose minus aithe minus, plus aithe plus, with proper sign convention you have to put it. Clear? Right? Now system of charges, electrostatic potential energy due to system of charges. And suppose more than two are there, for example in this fashion, like this, 1, 2, 3, Q1, Q2, Q3, okay, and the distance code, for example, this is R13, R12, R23 distances. So system of charges are there, Q1, Q2, Q3. Now how to get the electrostatic potential energy? Net. So U net is equal to U12, okay, due to these two, U12, alage U23, alage U13. చూసుకోండి U12, U23 and U13. U12, U23, U13. This is the electrostatic potential energy due to the system of charges U12, U13 and U23. So when you add up all those values, K, Q1, Q2 by D, distance R12, alage plus K with proper signs, Q2, Q3, distance R23, plus K, Q1, Q3 by distance R13. This is the U net. Total electrostatic potential energy due to system of charges with proper sign. If minus is there, you have to use minus there. I told you, only in the case of kinetic energy it is positive and intensity is positive, and force of attraction, repulsion, there you are not taking signs. But in the case of potential and potential energy, sign convention is very, very important, please. Okay, so this is how the E net is calculated. Next one, what is change in potential energy? Okay, change. How to calculate change in potential? That means work done is also equal to change in electrostatic potential energy. Work done is also called as change in potential energy. This is got by U final minus U initial is equal to work done. Final potential energy, final electrostatic potential energy minus initial electrostatic potential energy. Difference in this is equal to work done. That is called a change in potential energy, electrostatic potential. And the final potential energy minus initial is equal to work done. Clear? So for this we have a formula also in terms of torque. We have also in terms of torque. Already I have explained before. Suppose this is a field here in this direction. Okay, and suppose it is making some angle. So what is the torque? Torque is given by vector P E sin theta, and is also written as P cross E because it's a torque vector quantity. Okay, but here we are trying to calculate potential energy. How to get potential? By integrating you will get it, because sin theta ki minus cos theta within the limits theta 1 to theta 2. but I am not using directly, I am giving P dot E vector. మీరు దీన్ని ఇంటిగ్రేట్ చేస్తే PE కాన్స్టెంట్ పక్కన తీసి ఇంటిగ్రల్ ఆఫ్ సైన్ థీటా ఏంటి, డెరివేటివ్ ఆఫ్ సైన్ థీటా కాస్ థీటా, ఇంటిగ్రల్ ఆఫ్ సైన్ థీటా మైనస్ కాస్ థీటా, లిమిట్స్ థీటా 1 to థీటా 2, అప్పర్ లిమిట్ మైనస్ లోవర్ లిమిట్ పెట్టుకోవచ్చు, బట్ ఐఎమ్ నాట్ టెలింగ్ ఆల్ దోస్, డైరెక్ట్లీ ఐఎమ్ గివింగ్. ఓకే, దట్ ఈస్ వాట్ electrostatic potential energy or work done is given by minus P dot E. Minus P dot E ఏంటి, P E cos theta. So theta ఇక్కడ ఏంటి, it can take values theta 1 to theta 2, theta 1 lower limit, theta 2 upper limit or upper value, upper limit or upper value please, lower limit or lower value, upper value. ఎందుకు ఇలా చెప్పానంటే ఒక్కోసారి ద డైపోల్ ఇస్ రొటేటెడ్ ఫ్రమ్ లోవర్ యాంగిల్ టు హయ్యర్ యాంగిల్, అప్పుడు ఈ ఫార్ములా మారుతుంది. ఎలా మార్చుకోవాలి అప్పుడు, వర్క్ డన్ ఏం చెప్పాను, యూ ఫైనల్ మైనస్ యూ ఇనిషియల్. సో వర్క్ డన్ యూ ఫైనల్ దట్ ఈస్ మైనస్ పిఈ కాస్ ఫైనల్ theta 2 minus PE cos theta 1. So work done change is equal to minus PE cos theta 2 minus into minus plus PE cos theta 1. If you take work done PE constant outside bracket low, cos theta 1 minus cos theta 2. So this is how you can write down. This is general formula. PE outside if you take cos theta 1 minus cos 3, you can apply this formula or directly this formula. Okay, work done in rotating, work done. Okay, work done, that is potential energy please. Work done means potential energy minus PE cos theta. What is the total electrostatic potential energy in rotating from one angle theta 1 to theta 2? Minus PE cos theta లేదా PE into cos theta 1 minus, for example చిన్న ప్రాబ్లం, for example theta 1 is equal to 0 degrees, suppose theta 2 is equal to 90 degrees. So what is the work done అని అనుకోండి, you can put this formula, this ఏదైనా ఒకటే, ఏది చేసినా ఒకటే, u final minus u initial, లేదా డైరెక్ట్లీ can put like this, PE into cos theta అంటే cos 0 minus cos 90. So PE cos 0 1 minus cos 90 0. So what is the answer? P. ఇలా చేసిన అలాగే వస్తుంది, ఇలా చేసిన అంతే. You can also go like this, minus PE cos theta, first 0 degrees, minus, ఓకేనా, మైనస్ PE cos 90. ఇక్కడ వేసాం కదా ఫార్ములా, u final minus u initial, u final minus u initial, you can put it here, PE into cos theta 1 minus cos theta 2. Same formula, ఇదే ఫార్ములా I have applied here directly. ఈ కన్ఫ్యూజ్ ఉండకూడదని you can apply this one. This is original formula, minus P dot E లేదా minus PE cos theta. Okay, so here work done means what, electrostatic potential energy u final minus u initial. అందుకే రాసారు minus PE cos theta 2 minus PE sin theta 1, minus PE cos theta 2 90 degrees minus PE cos theta 1, minus PE cos theta 2 minus PE cos theta 1. If you apply, what happens, PE cos 90 0 minus PE cos 0 ఎంత 1. So minus into minus plus 1. So PE. So that is 1 into PE, that is equal to PE. ఏదైనా ఎలా చేసినా ఒకటేనండి. In any way if you do it, the value is same value you are getting. Okay, so work done is given by u final minus u initial. Okay, in rotating the electrical dipole, u final minus u initial, u final అంటే minus PE cos theta 2 minus PE cos theta 1, minus PE cos theta 2, u final minus PE cos theta 2 minus PE cos theta 1, minus PE cos theta 2 minus into minus plus. So PE common is the cos theta 1. Either you can adopt this formula or the above formula, u final minus u initial. In any way you will get the same thing. Okay, will you do one more and last problem for this one? Part 3. Last problem, that is, for example, theta is equal to 0. Theta is equal to 0 and theta is equal to 180 degrees. Both methods I want. Entadi minus PE cos theta, work done. That is U final minus U initial, work done is equal to potential energy. U final minus U initial and minus PE cos theta 2 minus PE cos theta 1 minus PE cos theta 2 cos 180 minus 1 minus PE cos theta 1 cos 0 1. So minus into minus plus PE and PE minus into minus plus P into 1 PE 2 PE. Direct method. This is original form. Direct method enti work done PE into cos theta 1 minus cos theta 2 cos theta 1 cos 0 1 minus cos theta 2 cos 180 minus 1. So PE into 1 minus into minus plus 1 1 plus 1 2 into PE 2 PE 2 PE. See, both the methods answer is same you are getting. Okay. So this is end of part 3 in electrostatics. So we will be dealing capacitance. What is the capacitor? Series connection, parallel connection. Okay. All those will be dealing in the next part, part 4 of electrostatics, please.